Hey, it's Chris. I saw that there was a forecaster bounty to create a Hangman Nillion game, and that's what I did. I didn't get to participate by the submission, but here's what I built. My two goals for this project is to build some sort of healthcare education type of game, and for number two is to, instead of building a Hangman Stickman type, Falling Man is something that I'm more interested in. To make a healthcare education type of game, I started with a healthcare JSON file that I created, and I wanted to pick four categories to focus on, and those being modalities, diseases, terminologies, and Web3. And for each categories, we'll see that there's a subtopic, and that each of these subtopics will contain at least 5 statements, and these are the statements that the player will need to try and guess correct. The trick is that these 5 statements will get mixed in with other 5 statements, and we'll try to get the player to select the correct one. Each statement will have a 3-letter code that will be used as the secret integer inputs for the Nillion game. There's also an assigned letter that's going to be used for each statement, and that will be used to help the player try and determine what the secret word is at the end of the game to win. To start, we'll go ahead and connect to Snap to get our user ID. In this simple Nada game, we declared a single party named Player1. This party will be assigned to the program's input and outputs. We do have a loop that will create the secret integer input data types that will be in the format labeled statement code 1 through 5. And likewise, there'll be another loop that creates an output labeled my output 1 through 5. In the results, we are basically looking for a 0 value, and because it's taking the difference between the player's inputs and the statement code values. And this will tell us if the player guessed the statement correctly. What's also not shown here is what we're going to do with the secret word. And in this case, we're going to make use of a secret blob that's found on the JavaScript client for the Nillion. And this will allow us to store a secret blob, which will be the secret word. And what we can do in the game is we'll retrieve this secret word, and we'll just perform a comparison to see if the player guessed the correct word. Let's go ahead and pick a topic so we can start the game. I'm going to pick modalities, which is basically a term in healthcare that's used to categorize the different diagnostic imaging systems in healthcare. Those are like CTs, X-rays, MRIs. When we selected the topic, what just ran was this handle game start function. In this function, other than setting up some of the React state values, it's also triggering this init game and secrets function here. So let's take a look at that. In this ETH scaffold Nillion repo, we are provided several helper functions that I wanted to utilize to make this game easy to create. The first one is this store program here we can see here. In this store program, so if we take a look at the code, we can see that here. Here on line 6, we can see that it takes the compiled program from this location here, and then it basically turns it into a unit 8 array, and it stores it on the network using this store program on the Nillion client. The next helper function is this store secrets integer. And there are 3 main steps on here, and it's basically converting each statement secret code into a secret integer data type to store on the network. It's also creating a program bindings to add to the input party, and then we're setting up permissions on the secret values. And in our case, we're not setting up any other parties, so where there's no other permissions to give. And once we perform the storing of the secret integers, we are given a store ID for that process. The last step is to store the secret word. In this case, we will use the store secrets blob, as we can see here. And if we look to store the secret objects, what we need to do is take our value that we passed into this function, and we're using this text encoder to encode the value into a byte array. And there's no bindings that's needed to be done for the secret blobs, but we do, and if we wanted to, we could add permissions. In this case, we're just setting up default permissions for our current user ID. Once the secret blobs is stored on the network, we are given another store ID for that, and we're basically then just combining all the store IDs we got from the init games and secrets, and we're storing it into this one config object, which we can then retrieve later when we do our computations. Now let's go ahead and pick a statement from our game. So our healthcare topic is modalities and an X-ray. So let's see if this first statement here empowers patients by giving them visibility into who accesses their information. Let's see if this is a correct statement pertaining to this topic. As you can see here in our scoreboard, we have one failed attempt for the incorrect statement that was selected. We can even see our Nillion falling man taking a step closer to falling off the cliff. That's bad. As we selected a statement, what was ran in our program is this check selected statement. And what's happening in this part of the code, it's performing the same store secrets integer as we've seen previously, and it's taking that code from that statement and performing the same process to store the secret integers on the network. And then from there, it's going and running a compute process. In the compute helper function, what we can find is that it's basically creating a program bindings to start, and then we're defining our input and output parties. In this case, we have player 1 as the input and output parties. And then what it's doing is, if we had any compute time secrets or public variables, that will be also processed here. But at this time, we don't have any compute time or public variables that's going to be processed. So from there, we run the compute method that's on the Nillion client. And this then performs the computation blindly on the network, and it provides us the results. And if we go back and take a look at another program, what it's going to be basically executing, it's going to take the player's inputs and the secrets and perform this computation part and return us this output in this results list. Once the compute is ran, we'll get the results, and you can see in our React program that we're basically taking the results and we're looking to see if there's a 0 value that's been returned. That's basically if there's a correct statement selected, then the difference between the player's input and the correct statement, then it should give us a 0 value. And if it's not, then basically it goes through a process where we're updating the scoreboard and keeping track with the game whether the player has reached the number of failed attempts or not. So in the next statement here, was X-ray discovered by Wilhelm Conrad Röntgen? That was correct. And then now we can see that the assigned letter, the letter N, is actually now placed here. So now we have 1 of 5 letters revealed. Let's keep going. And this statement is correct. X-ray is often the first test done for injuries involving fractures. Let's try the next one. Captured its first image of a hand. I think this might be correct. And this is also correct. Now let's pick the next one below it. Overcomes traditional barriers of data silos and incompatible systems. That looks like it's incorrect. And now we can see our hangman is beginning to come off the cliff. That's bad. Let's keep going down the list. Oh no, our stickman's falling. Maybe this one it might be right. Used in dental assessments to detect cavities and root problems. So now we have 4 or 5 letters. I still don't know what the secret word might be, but let's keep going and seeing if we can get the last letter. Employs a technique to visualize bone structures. This might sound correct. Oh look, so now we got all 5 statements. It's now time to guess that secret word. We have an N-E-S-O-B. Actually, it looks like bones. Let's try it. B-O-N-E-S. So here we go ahead and submit our guess, and it looks like we win. So what just happened there? As we submitted a word guess, what is happening in the program is we're running this handled word guess function. And what we can find as well in the function is a helper function from the Nillion ETH scaffold, this retrieve secret blob here. In this helper function, we're basically just running this retrieve secret method on the Nillion client, and we're passing in the cluster ID that's representative of the local Nillion network that's running. And then we have our store ID and our secret name. then we basically get back is the byte array of this secret and the decoded text value. And from here, once we retrieve that secret blob, and we're able then to compare the value of the player's input and that stored secret value and confirm if the player guessed the correct word. So this was a simple project to learn a little bit more about Nillion, and it's not a program. If you want to take a look at what I did, just take a look at my GitHub repo in the link below.